San Fernando City represents an important case study in fecal sludge management. It illustrates how a city can phase in services over time. Back in 2009, before this program started, the city had a big problem. There was really nowhere to discharge the sludge safely. San Fernando City is located on the island of Luzon in the northern Philippines. Before this program, drivers had to go all the way to Baguio, which was an 80-mile, one-way trip, just to discharge their load. The septage management program in San Fernando City was supported by an alliance between the United States Agency for International Development and Rotary International. Under this program, USAID provided technical assistance, while Rotary International provided funding for the facilities. There were a number of organizations and groups responsible for the development of the program. The Environmental Management Bureau of the Department of Environment and Natural Resources, along with the Department of Health, were key stakeholders. The first phase of the septage management program was sized at 30 cubic meters per day, and it's based on the demand model where people call for service when they want their septic tanks desludged. Implementers of this program focused in three main areas. The first is the infrastructure or the treatment plant. The second, the promotions campaign to raise the willingness to pay and awareness of the program. And then the third is the local ordinance or the rules and regulations that guide the program. Developing the local ordinance was a collaborative process that took about 9 months. It includes the establishment of a city wastewater management council that oversees the program and is the decision maker for all septage management related issues. The local ordinance sets the rules, policies, and procedures for complying with the city's septage management program. There are detailed sections on proper septic tank design for new construction and how to abate nuisances from imminent health hazards from poorly operating facilities. Owners of existing buildings or structures must comply with the rules and regulations when the building is sold, if there's a substantial remodel, or if the city engineer or health officer finds an imminent health hazard. The ordinance also specified the location of the septage treatment plant, and in this case, it's located right next to the sanitary landfill that serves the city. Here's a closer look at the site for the septage treatment plant. The facility itself is at the bottom of the screen, but the site goes all the way up to the road, so there's lots of room for future expansion. And here's a ground view of the facility. The septage treatment plant utilizes an anaerobic baffled reactor, followed by an upflow anaerobic sludge blanket filter, followed by sewage lagoons for final effluent polishing and disinfection.
This is non-mechanized system. Well, it starts with taking out of the debris, the trash, through screenings.
Here's an image of the newly installed screens. They're designed to tip up easily so that the operator can empty them into barrels for easy disposal to the landfill.
After this, there's a splitter where you get to choose which grit chamber you want to use. And there's a gate there that you can close every now and then if you're doing maintenance. They're servicing it right now. And this side is the drying bed. The solids deposited after 2 years is taken out from the anaerobic pond and dried here in a covered drying bed. So to keep the rain from making the sludge again soaked by the rain.
The drying beds are constructed with sand and gravel layers over an underdrain system. After about 2 to 3 weeks, the sludge is sufficiently dry to be either removed to the landfill for final disposal or composted on site for use in plantings.
The overflow coming from the septic tank will be received by either of the two tanks here. Actually, the setup is a 2 parallel anaerobic system. The one with covers, this we call anaerobic baffled reactor. These are multi-chambered septic tank that the incoming waste are digested through the utilizations of anaerobic bacteria.
Here's an image of an ABR under construction. This simple technology is responsible for reducing the BOD and TSS of the incoming waste flow by about 70%.
The open part, we call the upflow anaerobic sludge blanket. The reason for applying this setup is to reduce the organic load utilizing smaller footprints.
The upflow anaerobic sludge blanket reactor is a single tank process. Wastewater enters the reactor from the bottom and flows upward. A suspended sludge blanket filters and treats the wastewater as the wastewater flows through it.
4 meters to 6 meters is the typical depth of what we use in this upflow anaerobic sludge blanket tank. After a while of continuous dumping of sludge, the deposited solids needs to be taken out. 3 to 5 years in interval, depending on the frequency of loading, we're gonna send to the treatment facility. Next to the facultative pond is another secondary facultative pond. By the way, we're looking at the maturation pond. This is supposed to be much similar to the facultative process, but the intention here is to reduce the numbers of E. coli or pathogenic bacteria.
Maturation ponds in this example are designed primarily for pathogen removal. They're very shallow, about 0.9 to 1 meter in depth, to allow light penetration to the bottom of the pond and allowing aerobic conditions throughout the entire depth.
Doing disinfection by natural means is to apply a series of maturation pond, averaging of around 3 days retention time, and compared to other lagoon systems that we worked on before, is that we make use of the common walls. These are reinforced concrete walls that they get to share common walls, thus save in the civil works construction.
Traffic flow was carefully considered during the design phase of the project to allow easy ingress and egress for the desludging trucks.
We provided here a rotunda that the traffic flow is considered in the delivery and also for the exit of the trucks.
During peak times, the facility receives between 5 and 6 truckloads per day. This will expand, however, when the facility is expanded later this year. While this is a passive system, pumps are used from time to time for certain operational activities.
2 submersible pumps that every now and then that they can use to dislodge the contents of the tanks when needed.
So what can you tell us about these pumps? You got 2 pumps in here?
Yeah, we have 2 non-clog submersible pump in there that is level actuated but can be manually operated as well. That every now and then when the 2 tanks, the receiving tanks get to be filled, the operator can turn it on so it can overflow to the downstream tanks. And this submersible pump, as mentioned, can be utilized for the sludging of the anaerobic ponds and the facultative tank as well.
The septic treatment facility at San Fernando City is designed to be easy to operate. A manual for the operation and maintenance of the facility was prepared that specifies routine tasks, emergency operation procedures, and health and safety requirements.